Hi everyone, welcome to my live stream again. Today it's amazing weather outside, but we're gonna spend some time outside later on. The idea for today is to showcase all the stuff Memgraph can do. I hope that's gonna be interesting. Basically, I'll try to cover a bunch of stuff from the features perspective, from the basic stuff to more advanced features and capabilities. Especially, I'll try to do some stuff on the streaming side, how to ingest data from the streaming source. And yeah, I hope it's gonna be interesting. As always, please like, share, subscribe if you find this content interesting. And yeah, CDuck is here again with me, but the problem is that it is not focused. Yeah, it's a bit challenge to figure out the exact setup so that both CDuck and I are in focus, but yeah, since we are using the specific focus mode, let's leave it like that. Let's leave it like this. All right. If you have any questions, please post them in the chat or on any social media you like. Let's check what is going on. Nothing much. So we are ready to go. All right. We are good here. Anyway, so let's switch here. I'll start by simply installing Memgraph and playing out with basic setup. So let me first go and check how to actually install Memgraph. So if you go under memgraph.com, there is a download page that specifies different ways of installing Memgraph. So there is Docker image, there are Debian and Ubuntu packages, there are CentOS packages, and yeah, these are all the ways how you can install. Under the docs page, there should be detailed instructions about that. If we go under installation, we have all the things mentioned here. So on macOS you use Docker, but since I have an Ubuntu box here, I'll try to follow these steps here. This is a native install. I'll try actually to skip that. Interesting. We are here performing the native install, which is fine. But let me install Docker by copying this thing here. What's gonna happen here? Okay, image is up to date. I already have a Memgraph image here. One of the interesting things that we published relatively recently, there was the platform package, but it's not specified here. Let's go under Docker Hub. Docker Hub, and if I search for Memgraph Platform, so this is a relatively recent package which is available on Docker Hub, where all the things are packaged in one place. So Memgraph Lab, Memgraph Console, and Memgraph, and everything is configured and available and ready to be used. So I'll try and quickly try to run that. Maybe this will take a bit longer to download because a bunch of stuff is inside that package, but hopefully it won't take too long until that's up and running. Yeah, I've again do the same mistake. Let's move here. Just see. All right. Anyway, with the regular Docker image of Memgraph, we can do docker run Memgraph, and then if we put here at the end of the command as a last argument -- help, it should print all the Memgraph flags, runtime flags. So here you can see a bunch of stuff. In one of my early videos, I've covered most of these things. I'll just try to run Memgraph with some of these things which are most interesting. But anyway, let's close. So now we have this. We don't need this window anymore. Let's move here. So I can just start another Memgraph new session. Yeah. Okay. Here we can do more stuff. So docker run help. Now we see a bunch of these flags. So that's fine. I'll come to that a bit later. Let's try and go back and try to run that platform thingy. So if here we are missing a couple of information, and do we have that on the yeah, we actually don't have that yet on the documentation pages, but we'll add it at some point soon. Anyway, I'll try and go with the flow here. Docker run minus, so we need to expose IT is a standard Docker stuff. Maybe I can make this. Yeah, I think on mobile devices my screen is not that visible, so I'll try to use these big fonts just to see how does that look like on mobile phone. So yeah, if you don't like how big that is, please let me know. Let's try with this size. So docker run minus IT, these are the flags that will attach to TTY, and we'll be able to see the output of Memgraph. And yeah, we have to publish 7687. So these are the ports that Memgraph operates on, and I think we also need 300 because Memgraph Lab, so Memgraph Platform contains Memgraph Lab inside, and I think, if I'm not wrong, that's on the port 3000. Memgraph Platform. Memgraph Platform. Okay, I think that should be it. So if I run this, what's going to happen? Nice. So now we have, so Memgraph is up and running in the background. Let's check that. So docker ps. So we have these two ports published, and we have that. Okay, if we attach to Docker minus t bash ps, we actually don't have. Not sure. what's going on here, but we should be able to connect to Memgraph. So if we match and here, it's working. So yeah, we have the Memgraph up and running here. I'm not sure why PS doesn't print stuff here, but doesn't matter. It's up and running. All right. So here we got Memgraph console already up and running, and we are executing queries against this Memgraph instance, which is amazing. Also, we have that port 3000. Let's try and run. Let's try to connect to that. If we go under localhost 3000, boom, we got Memgraph Lab interface, which says localhost. I think that should work because it's configured to be connected to this port here. Yeah, this is now interesting because to accept encrypted connections. I think that's a wrong error message. Boom, I think that's a wrong error message. But okay. How to actually connect inside that Docker, because it should be able to connect to localhost because we are running Memgraph on the same machine. Interesting stuff. Okay, if I run Memgraph Lab, so we have installed Memgraph Lab here. If I use localhost, so it's working. The problem is why that box doesn't work. Let's go back here. Localhost 687. We have that, and we have that. It should work. So this is like in the browser, and that instance of Lab is connected inside Memgraph. Is available inside Memgraph, and it should work. Let's inspect this a bit. So can we see somewhere? Yes, but do we have that public on our GitHub? Probably that's not public yet. It's going to be. Yeah, it's not yet public. Okay. Okay. I think we won't be able to use this because I don't know how to connect. But okay. That's something we should fix probably. Just let me write that down. All right. Okay. For now, we're gonna use the Memgraph Lab, which comes with self-installation. So let's close this. But yeah, let's go back to the terminal. Now we have the console up and running. If I close this, what's going to happen? Docker PS. Yeah, Memgraph is deleted. Docker Rama gifted relaxed peaceful. Let's So this command docker rm is remove all the containers, and that's fine. And what I'll do here, I'll put here minus rm. That will automatically delete the container once it's stopped. All right. So anyway, we can run memgraph again. Here we can do some basic queries. For example, if we want to create two nodes and one edge in between them, we just execute, let's say, name John, and we put here, let's say, our friend of Lucy. This query is gonna create two nodes and an edge between these two nodes. We can return n and m here. So we successfully executed this query. We have these two nodes and we haven't returned edge, but that's fine. We can do this by running this query, match n r return n r m. This query is going to match all the nodes, hop once through the available edges on that node, and then come to the node m, and then all these triplets of results, let's say, of matched data will be returned. And since we have one of these, that will return these things here. So let's go to the lab. Lab is showcasing on the overview screen. Lab has number of nodes, number of edges, average degree, and some operational data, memory usage, and disk usage here. Since I do have some queries here, but we're gonna type this again, match, and here lab is doing some autocompletion stuff, but for the simple stuff it's not that useful, but we'll see on more complex examples how that could be useful. Return, we can do that here, and rm. If we hit here control enter, that's going to execute the query. We have John here and Lucy here. Basically, that's a very simple example of how to add data inside Memgraph. Let me go a bit back. Okay. All right. Let me go a bit back by reconfiguring Memgraph. I do know that we have a not supported feature here, so Memgraph Platform cannot have flags yet here, but we're gonna figure that out. That will be supported as well. I'll now just switch to the regular Memgraph. So we're gonna run memgraph /memgraph. This is a regular query to run Memgraph instance. And then if we put here help, that's gonna print all the stuff. Not sure why this returned 1. Yeah, probably that's fine. That's what we return when help is printed out. Out of all these flags, I think the only one that from the database perspective, this one is very interesting. Sorry. isolation level. So you can set an isolation level. I can record a video only about that. That basically which data you'll see if you run Memgraph, if you run queries in a concurrent mode. Let's say many queries at the same time. But that's quite advanced. In terms of basic stuff, I think the only interesting one is storage properties on edges. So by default, that's false, but in the, let's say, Memgraph binary, we enable that because most of the time you need properties on edges. For example, if you have some kind of weight between two nodes or something like that, it's very convenient to store that data on the edge. So you have edge type and also some kind of weight or any other type of information, and mostly you need edges. But if you don't need properties on edges, then you can save a lot of memory because Memgraph is completely ignoring that part of the memory. Actually, like a lot less memory is used, and it's very convenient to just set that to false, because, and it has to be done explicitly because it's currently by default in that binary flag is set to true. Yeah, but again, that's also a realistic case because if in some of, let's say, social network connections, social network example, you can also have only the edges between nodes. You don't have any attached information to an edge, and in that case, that flag is very convenient. So let's try that out. If we put here minus minus, where is that flag? Just to not put it. Storage properties on edges. So we, by default, it's enabled. We want to disable that, and we put false. And yeah, that's maybe one interesting example, one interesting query. But we also want to add here a couple of other useful flags, which I always do on the live stream. That's log level, which is by default info. But if you put here trace, then a bunch of stuff will be printed out during the Memgraph runtime that will help you debug stuff, and also log to std error. So that will print all these logs on std error. So you will see these logs here in the terminal while interacting with Memgraph. So these two are useful for debugging purposes. If I run this now, so as you can see, we have a bunch of these logs here, info warning. So, but these would be printed out in any case, I think. And we now have Memgraph up and running, which is amazing. That's also passed, so I think that should be enabled. So if we go now back to the lab and we try to create these, so let's say I go back and I create name John. Let's do the same thing here. Our friend of, oh sorry, we'll do without. We'll see, yeah, we'll just try to create that. Now the query works. We can see there is an edge between these two, but if I now run, copy to clipboard, if I now run that, but by, let's say, weight 100, this query should fail because we cannot store these properties on edges. So it says query failed, can't set property because properties on edges are disabled. Again, this is, let's say, benefit in the operational case when you want to limit or reduce the memory usage of Memgraph. But yeah, that's how these things usually work. And here, let's go back here. Since we put log level to trace, we can also see debug stuff here. Since when you put a log level to trace, you will basically see all the log levels. It shows all the log levels above. So trace, debug, info, warning, and error. Here we can see debug. So we executed these two. We executed the create query. Show storage info is Memgraph Lab query, which is executed automatically from the Memgraph Lab. And then we have these count queries. That's also Memgraph Lab here. And we have when we attempted to execute a friend of query with wait, it said error message, and basically that was returned to the client. Okay. Anything else on this side? I don't think so. Let's go back to the terminal and then just execute Memgraph without this, because we will need properties on edges. Boom. All right. Here we have these info logs that query modules are loaded. I'll come to that later on. That's fine. Let's go back here. I'm not sure if I restart, can I still run this? Yeah, but just since we restarted, we have zero data in, which is okay. Okay, let's put some data in. We have various ways of importing data. Let's go back to the docs pages. So import data. There are multiple ways of importing data into Memgraph. You can import data through the CSV load, CSV close actually. So let's check this a bit. So if you have these node, you can do, if you have this CSV file, you can do query like this. Maybe I can just this is, I think, perfect. So all right, it basically says load CSV from path to people nodes with header as raw. So we specify that we want these headers because then Memgraph will return a row, and row will have the exact let's say properties fields on that object, which are ID and name. From here is the ID and name, and then later on in the query we can create a person and also relationships between these people. A tricky thing here, let's actually do that. Let's showcase that, because if you're in if you're running Memgraph locally, then you probably can figure out these paths locally, and that's going to work. But inside Docker, it's a bit trickier because you have to inject data into Docker container which is running to be able so that Memgraph knows where these files are, so that because Memgraph can access the file system inside the Docker container. So I'll try to do that. It's not, we'll update that here, but it's not very well explained at this point. It's not obvious how to do that. So I'll just quickly do that for the sake of running stuff. So let me go back. I'll start new thing here. Workspace. Let's create mkdir dmp. Just create another folder. Doesn't really matter. So this file is called people node CSV. Let's create that file. People node CSV. People node CSV. And I'll copy that in. Amazing. So we have people node CSV. And then I'll also do people relationship CSV. Get, oh sorry, people relationship, and I can actually copy here. All right, and in this case, we have these two files, and now if we execute this command here, it's gonna massively fail because Memgraph doesn't know where the file is. And the easiest solution at this point is to copy these files. Just to, so Memgraph is here up and running. Docker PS, we have that container called magical McClintock. So we'll copy these things. We'll copy these two files into that container, and that's done by docker copy. Or docker cp, sorry, docker cp. Yeah, so it says docker cp options. I think we don't need options. Archive follow link. No, we don't have symbolic links or anything like that. So we specify container, source path, and destination path. But that's in case we want to copy from the container to the local file system. In case we want to copy from local file system to the Docker container, we basically run this command, source path, and then put container ... destination path. So let's do that. Docker cp people nodes into magic McClintock. Yeah, it already has the autocompletion with ... and then slash people nodes.csv. Boom. Yeah, I hope this worked. It's actually here, it's a rocket, so it works. That's really useful thing actually to have in the terminal. Docker cp people relationships magical CSV. Again, successful. And then let's just check that. So maybe we can be a bit smarter by so here we have people node CSV and people relationship CSV. Okay. And that's on the root, inside the root folder. I think this query now should work. If we run this command, boom, amazing. So we have these 5 nodes in there, which is great. Let's do edges now. The query is this one here. Yeah, here we also need to add that zoom somehow so that I can showcase that in a better resolution. So people relationships, boom. It says here no data found, but query exited, there is no error, so query exited successfully, and we have actually 5 edges. And now if we run this query here, which is give me the node, that's the graph we have. So Lucy, Sarah is friends with Lucy, Daniel is friends with Sarah, etc. We have these IDs here, which is great, and that's basically it. So maybe a disclaimer here, this is a really small example, and it's always important to start small, start slowly, because otherwise you deal with too much complexity at a given time. So we're gonna get to the bigger examples, probably not today, but at some point definitely. But yeah, on these small graphs we can basically showcase a bunch of capabilities without worrying too much about scalability issues. But by the way, Memgraph is really helping with scalability issues, and we are trying to figure out the most scalable things and the most scalable ways to do stuff. All right, we have that graph. I'm pretty happy with this graph because I can showcase a bunch of stuff I actually planned to showcase, which is amazing. Okay, now we successfully import static data in, which is great. We can also use, so I think load CSV is probably the easiest way to import stuff, because you can have various CSV formats, and then by combining things here you can basically load whatever you have, and then later in the query you can figure out the actual mapping. You don't have to pre-process that CSV file and transform it to something else. That usually requires some way of some code, and that's time consuming. It's not hard, but it takes time. In addition to load CSV, if you have CSV file in this particular format, it's explained here. Basically, you need to have a certain header structure in place. In that case, by the way, the format is good and everything is fine, but you really need to have that format. If that's the case, then we provide the CSV import tool, which is packaged inside Memgraph. I won't showcase that this time, but again, this is a very similar problem, because once you have so basically this is the format, so you need to have a certain header in place, and once that's satisfied, then you can import. With Docker is a bit trickier, again for the same reason, because Memgraph is located inside Docker. Not just Memgraph, also the import tool is located inside Docker, and then you have to copy these files into the container, which is a bit tricky because there are many commands, and you have to do all that manually and stuff like that. Here there is a very specific thing inside from the Docker ecosystem that's called BusyBox. That's like a dummy container where which you can spin up to do stuff. Essentially, this is just used here to create these volumes that Memgraph will read later on. But yeah, that's the lightest way to do this. Once that's done, you can remove that container, and then Memgraph can import stuff, because Memgraph CSV import tool is creating a snapshot files. So these are files on the file system which Memgraph can read and then recover from these files. So this is a bit more, let's say, optimal from the import perspective, because the import tool is very optimized and it will dump these files in a very efficient way, and then Memgraph can read that in a very efficient way. The drawback of that is that it's not parallelized, so that's all single threaded. So Memgraph, at this point, Memgraph import tool is creating files single threadedly, and Memgraph is importing these files also in a single thread, which can be slow in case you can parallelize import, and in a lot of times you can. And for large data sets, that actually makes sense. CSV import tool is like you cannot think about it as something that will always work in the most optimal way. Not it will work always in the same way, but for, let's say, medium-sized data sets, that CSV import tool makes the most sense. So for super small data sets, it doesn't make much sense to use it, and also for super large data sets, it's not yet optimized for that. I would rather do that programmatically by executing Cipher queries, because then you can parallelize stuff and you can do incrementally. You can update things later on. So with this, you cannot do stuff incrementally. You can just dump data at once, and that will be it. After later on, you have to execute queries. So this is more or less like one-time op, if that's convenient. In the Docker case, that's, I think, a little bit more easier, because once you have the files, you just execute mg import CSV. Since Memgraph is installed on the system, that binary is also available, and here we just run that binary as a Memgraph user, because Memgraph will be started as a Memgraph user, and then Memgraph needs to be able to read these files. That's a bit easier, but again, the same trade-offs, the same behavior under the hood, the same things will apply. And that's CSV. What about Cipher? So with Cipher, there are more ways to import things. So with mg console, what about, let's do Linux stuff, because Docker is equivalent, but just a little bit more verbose, or I don't know how to say that, but yeah. Okay, mg console. Anyway, the programming language Memgraph uses is Cipher, and if you put L at the end, that means Cipher line, which means that this file has one Cipher query per line. And once you have that, you can simply pipe these things or redirect these things into mg console, and mg console will automatically execute that against Memgraph. That's probably the easiest way if you just want to play out, because you can write and, if you know, in this case you have to be familiar with Cipher. If you are in that spot, then these things is really convenient, because you can store this file, you can do something about that file. It's human readable, and you can extend the file piece by piece and then use it later on and stuff like that. So yeah, this is pretty straightforward, just piping stuff in, and that's it. For example, you can have, like, this is the example of the queries. You can just have one query per line, and Memgraph will ingest that. It's a bit more complex examples. Let's actually do that. So this seems like a bigger example. Do I have mg console here? am I in the container? Yeah, I have to go out, mg console. Yeah, I have mg console. No, Vim Cipher query Cipher lo. If we copy this, sorry, I'm not. Let's just save this here and let's go back. If we copy here, let's actually do another example. So since we have, if we run mg console here and we match n, return count n, that will return all the nodes, all number of nodes inside Memgraph. So we have something inside. We can run match n dash delete n. So that will delete the entire graph, because detach delete means, so we'll find all the nodes and then detach delete these nodes. Detach means that all the edges attached to these nodes will also be deleted. We can do like this, but we can also do like this. So echo, we can print that query, match n, delete n, and if we pipe to mg console, that is going to execute these queries against Memgraph automatically. If we run this, it was successful, and if we go back to the lab on the overview screen, now we have 0 nodes and 0 edges inside, which is great. Let's go back now to the documentation, copy the query, back to the terminal, copy paste these things. We can also redirect that inside into mg console, let's say. If we execute this now, it was successful again. If we go here, boom, Memgraph Lab needs to pull the latest info, but now we have nodes and edges back in. We have here latest queries. If we just press run, boom, now we have a little bit bigger example, which is amazing. That's actually, again, I think the same example, just with more edges. So who ate what? So Mia ate at KFC and she liked that. Amazing. Okay, that was about that. One more thing here, since we have that dolphin, or that's not dolphin, what's the English word for that animal? That this animal here, Docker. Docker, since we have the Docker here, we should also have some kind of a Linux icon. Let's write that down. Okay. Amazing. Let's stay here for now. Let's stop here for now. In terms of these Cipher queries. Let's figure out Kafka stuff. So, since recently our plan is to add a bunch of stuff on the streaming side and be very convenient and easy to use for the streaming. So we have a Kafka connector built inside and like integrated inside Memgraph. So it's very easy to stream data from Kafka into Memgraph. So how does that work? We can start Memgraph, we can define transformation module, we can stream data, That's all fine. I'll actually try to do that as well. Have a working Kafka stream, have access to Memgraph instance, importing data, start Memgraph with Kafka configuration. Do we have that? These are Memgraph flags. The thing here assumes we have a working Kafka instance. So but we have an example of that as well. Okay, here general info. Here is general info about stuff. We can do Avro as well. Do we have a transformation script? Yes. I actually didn't know about this. Nice. We can actually, we have the example on how to read Avro format. We can do JSON and we can do protobuf. Just to explain that, I'm not an expert here, but basically JSON, so Kafka message can be in any format. Most often that's either JSON or Avro format. JSON is more, let's say, unstructured because you can have various you can have any schema of that data inside JSON, and it's more flexible, so you can put whatever in, and then once you consume the message, you can decide what is what and what are the types of the data points and stuff like and stuff like that. If it Avro, there is a schema involved, so Avro specifies the schema of the data. So here is the schema. So like a name person, that's a record person, has name which is string, age is integer, and stuff like that. Company schema is another schema. We have like 3 schemas here, and then do we have example of this? No, we don't have examples of these things, but anyway, once a message comes in, it should be in a certain in that format. So for example, if a company address is an integer, that's gonna fail, and Avro will figure out, Avro will report a failure, and then you know that it's a failure. You don't have to deal with that. So if you want to be less strict, that's probably better in the beginning because you don't know what you're doing. Then JSON is a better way of start. And Avro is probably a bit more advanced when you know exactly what's gonna be what and how to do the what's the schema, and when you are a bit bigger, then you need a tool that will enforce the schema and keep track of all the changes and then report errors if something is bad, is not aligned to that schema or anything like that. All right, let's try run these things. So Kafka is here a bit undocumented because there is no example, or I don't see it. Let me know if I'm just ignorant. Create stream. An assumption here is that you already have a Kafka stream, and that's not the case at this point. So I'll use another repo, another example to start Kafka. I already did that on the streams. GitHub Memgraph example streaming app. So inside this repository, we have an examples how to build backend applications with Memgraph and Kafka in different programming languages. But that's not what I need. I need to run Kafka. I think I have that already in here. So example streaming app. If I initialize that, git co master, no, main. Let's do a little bit of cleanup. We merge that in between, so I'm gonna just delete that in trust backend. Git pull. I'll pull the latest version. The latest version only contains Rust backend, which is more or less in the finished state. So here we have example. So Kafka, we actually have the producer here, which is a dummy producer, but it makes the point. We have that run script which will download Kafka and run everything. So let's do this. I don't know, here under 5 Kafka. Kafka run help. If we run help, we can and yeah, with Kafka, to run Kafka you need a Zookeeper and Kafka. At this point, at some point, project will have its own implementation of, let's say, Zookeeper. Zookeeper is needed for these distributed operations when you have to synchronize and when you need some way of synchronization between services. And since Kafka is a distributed system, then they're using Zookeeper, but they will replace Zookeeper with some internal code. But I think that's not yet the case. Let's check that actually. Kafka GitHub. Let's yeah, I think not sure. I don't remember what's the trunk. On trunk I think they have the already the code that works, but sorry, I have that here. We are downloading Kafka and we are using default version. Default branch is trunk, so yeah, we have a trunk. We are using Kafka from trunk, and they have that Zookeeper stuff, and I'm not sure on which branch. They don't have Zookeeper. I think 0.9 or something like that. Let's check the documentation or something. So Kafka documentation. Now we ended up in a rabbit hole. Kafka Zookeeper. Let's search this. When was that? April 27th. Apache Kafka 2.0 is finally out, and you can now have Rolex to keep. 2.8. Yeah, that was the, that was, yeah, 2.8. And what's the, no. That's under Apache. Okay, sorry. 2.8. So here, supposedly they don't have a Zookeeper anymore. They use something internally. But anyway, that's on that version. Here we are using the trunk, and that's for our purposes. That's fine. Right. Let's close this. And let's go back in the terminal. So run. Run Zookeeper. If I run Zookeeper, boom. Okay, Zookeeper is enabled, is running now. If we go here, run, and we run Kafka, now we have Kafka as well. Let's go here, let's do this. Run consumer. We can also run the consumer. Now that's gonna consume stuff here. And if we, so if we start run producer, that will run producer test. Boom. So we have a running example of a Kafka. So we have here, we have a consumer, here is the producer, and if we produce test message, that's gonna get here. Great stuff. Let's go back here. So now we have running Kafka, but we were planning to set up Memgraph and import data from Kafka. Let's see what the documentation says. So mgload transformation. We have these transformations, or we don't have them. Start stream, check stream. So the whole example is covered under example streaming app, and there is the whole code. But I'll try to do this manually now, just to showcase stuff, and probably I will stumble upon some errors. But yeah, I need a quick break. Any questions? No one is actually alive. Come people, come and ask questions. All right, I hope, yeah, I haven't checked the stream much, but I hope everything is working. Yeah, the CDAC is here. I don't know how to, maybe this is a bit better. Yeah, okay. All right. let's try and run some stuff. We need a transformation. So if we run this query, we're gonna get nothing. Yeah, because we don't have the transformations yet. Now let's go back a bit. So we need some example. I think tutorials are don't have much of these things. Triggers, reference guide. Where do we have transformations? Streams, transformation modules overview, boom. Okay. MG transformation, MG API. C API Python. Let's do Python. Python is a bit easier. A lot easier, but yeah. Okay, here is an example of the transform script. So maybe a little bit of background here. The problem with transformation, the problem with these Kafka messages is that they are not in the graph format, which means we have to transform them from whatever format they are in, let's say JSON, into the graph. And that's not super straightforward because there is no like one-to-one mapping to the data structure because let's say JSON is a flat structure which has just, let's say, tabular data, because you have a key and value. You have basically each JSON, let's say a simple JSON is just a file where you have a bunch of key value pairs and that's it. And the question is how to transform that into a query. Obviously, into the graph. Obviously, you can store everything as a node, and then you can just pass that. That would be equivalent of storing these things into a table. Basically, for each field you would store as a row, and that's it. But that's not super useful for graphs because you need edges. You need some kind. You have to somehow extract values about the edges, and then you have a serialization, a way of serializing stuff as JSON. But when that JSON comes in, you have to say, oh, that's an edge in my graph, and I want to create that edge there. And that's the reason why there is a transform script. So we need some way of transforming these JSON messages into nodes and edges. Nodes are relatively simple, but edges are a bit more complex, and you have to find these edges and then these nodes and then connect them by creating an edge. But okay, in this simple case, we are just creating an edge again here, and we gonna do the same here in the beginning. So now I'll spend a lot of time, some time in configuring that with Memgraph, but it should be relatively straightforward. So here we have an import. We're gonna start a new window here. Oh no. Workspace, DNP, mkdir, modules, and Vim. Let's say if we awesome module .py. Let's paste this in that, shamelessly paste this code into that file. If I go out, okay, now we have an awesome module that is available here. I hope it's correct, but let's try to load that module. only that, which is amazing. Let's go back to Memgraph. Let's stop the Memgraph. For this operation, Memgraph has to be stopped actually. If I put here query modules directory, we can specify here query module directories, let's say. But before that, since we are using Docker, we also need to mount that. So -v, we have home mg workspace tmp modules, and we're gonna mount that into query modules inside Docker. So this is a mount command which will mount this host directory into this Docker directory on the Docker files inside the Docker file system. And if we pass that query here, so we actually want two directories to be listed. So basically Memgraph is loading things from here, but we also need that /query module. So, and query module directory supports multiple file folders. So we can say here usr lib memgraph query modules, but also we want query modules. That's going to work, hopefully. If I run this, boom, it says loading module from this folder and also loading module from query modules, also module.py. Amazing. So now we have that. Let's check inside Memgraph Lab. What do we have here? mg transformations. If we rerun this command again, boom, we actually have the transformation script available. But that's not it, because we have to actually start receiving data out of the whole thing. Let me go back to that module. And now we awesome module. What do we have here? So we have messages, total messages. We get multiple messages here. But yeah, if some of these messages fail, if that fails, I'm gonna try accept, and I'll just make a print, failed to process message E, let's say. Okay, if in that case that's going to fail, and we're gonna, that's what I forgot to mention. Once message is decoded, we have to actually return from the transform script Memgraph queries. So basically that's the interface. So Kafka message in, Memgraph query out. And that's the most flexible way of designing the interface, because you can do arbitrary stuff. So you can return arbitrary queries from that module, and that will be executed against Memgraph. And I put here the try catch block because just to avoid basic errors in the beginning, because otherwise Memgraph module will crash, and then the Memgraph module will fail, and like the stream will be stopped and all these things. So I think it's better to do like this. But yeah, maybe that's also questionable. I'll also write that down. Maybe we should extend that example. Example. Okay. I've changed that. And that's fine. And now the question is how to reload that. So let me go back to Memgraph. Docker is here. We call the transformation script, but so if we go under documentation again, where is that? That's Python. We have loads or reloads the given module, loads or reloads all modules. So load all, we're gonna use this to load that module again. Basically, no, I'll try actually with this. So, because I always do load all, but that's not efficient. Load all, string, module name, awesome. Module, let's make a mistake here. Let's try this. Fail to reload module. Yeah, if I do reload module, boom, that has passed. If we do this, so we close the module and then reload the module. And then load module again. Amazing, so that worked. All right. And now let's do, okay, if let's say we are here in the Memgraph area. Here we have Kafka. If we run Kafka, haven't I start Kafka here? No, here. If I run test here again, that's gonna come here, but Memgraph won't notice that at all. Memgraph don't care about me, about streams, about anything on that side. Okay, I'll try to. That's it, because we just have that transform module, but it's not attached to anything yet. So if we go under streams, we have to actually create a stream inside Memgraph. To do so, we have to specify stream name, we have to specify topic, we have to specify transform procedure, and then these extra flags, which I'll try to ignore them at this point because they are not that relevant for just showcasing stuff, but Memgraph exposed them and you can use that as well. So let me go back. Kafka, yeah. No, I have to do this thing. But Memgraph Lab has an awesome feature here called Autocompletion. If I do create stream, that will add stuff here. So create stream name is, I don't know, test stream. Topic name, yeah, topic name is a bit tricky because that's a data point from Kafka. And let's go back to Kafka. So this thingy here will create a topic, but I'm not sure if that was created. We had to execute topic command here, but I hope that was created. Can we just, use that. But yeah, I will just rerun that and see what's gonna happen. Kafka run topic. Topic already exists, so we already have the topic in that Kafka deployment. So I'm gonna just use that here as a name topic, boom, and transform namespace dot transform. Namespace is actually our module name, which is awesome module dot, and the transform is mg transformation. Where is that specified? Okay, sorry. Let's just no. mg transformation. That's the function name here. Sorry. Yeah, I was a bit confused for a moment. So transformation is the way to go. We need actually this awesome module transformation. Let's go back, create stream. So test stream topic name topic. Oh, I made a mistake. Topic transform. If we paste awesome module transformation, I think that's it. If we run this, boom, topic expected after what's the create stream topic? Probably we don't expect to, this shouldn't be a string. Wow, boom. Local broker transport failure. What is that? I never saw this. So let's debug. No. I think we stream name topic transform. Where is the we need to specify Kafka endpoint. Sorry. Topic, my topic, batch interval. That's a bad. Sorry. Memgraph has to be run with. So we need a runtime. Memgraph has a runtime flag, which says where Memgraph is connected to where Kafka is running. Streams overview, transform modules, la. But this doesn't say here anything. Create module, create a transform module, create stream query. Yeah, this is also a bit misleading here because connecting to Kafka, manage Kafka streams. Yeah, this is here. This is written here. Kafka bootstrap servers. It has to be set explicitly. Yeah, that's fine, but yeah, that's a bit strange. Let me write that down as well. Kafka ref guide. The flag Kafka ref guide should also have the flag. Okay. Memgraph. We know that, but we need to Kafka. Kafka bootstrap servers, list of Kafka broker as a comma separated list. Or host port. Localhost, okay, Kafka broker servers. So we need here, so Kafka servers equals localhost. Usually Kafka works on, so example streaming app, we have Kafka here under localhost 9092. Localhost 9092. What? Bootstrap servers. Loading streams, loading triggers. Okay. What is happening now? We have that. Let's now try and execute this. Something else is broken, because yeah, by default that should work. Awesome module transformation. Topic local broker transport failure. Yeah, sorry. The problem is that I'm inside Docker and localhost doesn't have that thingy. So since I'm in Docker, Memgraph is run inside Docker. Problem is that Memgraph doesn't see Kafka. That's another hypothesis. Let's test it out. What's the best way to do so that I think the best way, I think we also have that in the example streaming app. If we go here, we go under Kafka, under Memgraph, run. I think we do stuff with the host. Yeah, network host. Yeah, okay. So let's restart Memgraph again. So Memgraph needs, no, that's not a Memgraph flag. That's Docker flag. Let's put it at the end. Network host. So by doing this, Docker container will see the host network and then should be able to connect to Kafka without issues. If we run this, okay, now we have Memgraph again. Let's try to execute this again. Now I think that successfully exited. Yeah, I think we need a message here or something, because it's very every time I see no data found, I'm confused a bit. Something green, add something green. To the lab after query. All right, sorry, I'm taking these things so that we can fix them and improve them. Okay, we have that. So now we can do show streams command. Boom. We have test stream topics list. If we expand that, we have a topic. And these things we didn't change, and then we have the transformation is running false. So we are not running that transform script, that stream yet. Yeah, let's go back to the example streaming app and to our Kafka stuff. If we do test here, all fine here, but Memgraph doesn't know about that yet. So in order to run these things, we have to run start all streams. Wow, we have that. But okay, we're gonna do start stream. Stream name is test stream. If we run this, again, no data found, but if we rerun this query, show streams is running true. And now executing query, start stream, Kafka consumer received local broker transport. It's processing a batch. Test stream, we actually got payload test. We have test, but okay. Sorry, where is that? So here we are decoding that, and we are just putting payload. Yeah, we are just putting payload here as a test, and but that should be inside Memgraph already. Yeah, so we have that one node. If we match that and return, and we have that message, which is payload test. Payload test is here. Amazing, we got that. Let's do more stuff. So now we have stream which is up and running, and let's push more. One more message that's gonna come here, but that should also come here. Boom. Now we have two. So Memgraph is continuously getting data from Kafka. So we have test, and we have one more message. Let's do one more. Third. Boom. That's here, and it also should be here. Boom. So now we are creating these nodes inside Memgraph. What's really good now with this setup, because on one hand you can have a Kafka cluster up and running and processing all the messages, and on the side you can also have Memgraph consuming these things and also storing these things locally. So let's say in case something crashes, let's say we stop Memgraph for some reason, or Memgraph has a bug or anything like that, Kafka is still running. So let's say Memgraph is crashed here. Memgraph doesn't work anymore, and then we produce another message. Let's say Memgraph is not alive now. Boom, we got that as a message. Here this doesn't work because we are completely gone. Now if we rerun Memgraph, let's rerun it. So we loaded all the streams and everything. Let's run it again. Yeah, problem is now the problem is that I've actually completely deleted all the data inside Memgraph, because that's in another Docker container, and then Memgraph didn't recover the original data set. To do that, we have to mount the volume. That's now that's now in the domain of a proper deployment. We should put data on a volume, but let's do that. Why not? Just a second. So instead of doing like this, we should save data somehow, and between these runs of Memgraph. So this is now a very Memgraph specific, a very Docker specific, but doesn't matter. We'll do it. mg data, and now var lab Memgraph. So this is the path on Linux file system where Memgraph stores the data, and once we mount that volume. So in this syntax here, mg data is a named volume inside Docker, and it's mounted to the varlib Memgraph inside Docker container, and that tells Docker that next time Memgraph is started, it will load data from this directory. So we should now have persisted storage of data. If we run this now, we have the things here. Everything is running. I think, yeah, these triggers and streams will be stored inside that directory, so we'll recover that as well. So Memgraph will recover that. Let's go back here. If I run show streams, nothing is there. If I run, and that's correct, because we started a new volume and everything is started from scratch. We have the transformation module here. Now if we, so that's an important thing, show streams, nothing is here now. So if we create stream now, create stream name test stream, topic name topic, namespace awesome module nation. I think that's correct. Yeah. Now we have so show streams. It's not running at this point. Did we maybe fetch something? No. Okay. Start stream test stream. We're gonna run that, and if I go back, show stream, boom, we have that running. Did we now push? Yeah. So now we fetched one node because there was one message that Memgraph didn't consume. So when I crashed Memgraph, we lost. We lost. I mean, Memgraph and Kafka were not connected at that point, but Kafka still had that message stored. And when Memgraph came back again, he pulled that one unconsumed message back. Since we didn't have since we didn't configure Docker properly before, we don't have the data from before. But let's do the same now. So let me first crash Memgraph so that these things should be recovered. So if I now crash Memgraph, let's say something happens, you have to restart. You do, I mean, you know, in the normal environment, in the normal operational environment, you do some stuff with the service, with Memgraph, and let's call it again. So test stream is loaded, loading triggers, that's all fine. Now if I query again, show streams, we have the stream, so that it's fully recovered, and we also have is true, so the stream will be running again. So now if we create additional stuff here, so let's say 1, 2, 3, we created these 3 messages, and let's go back here. Memgraph consumed all of these 3. Let's go back here. So we have 3 of them, 3 more of them, and they're all in the graph, which is amazing. Now let's say that we stop Memgraph for some reason. We stop Memgraph for some reason, and we go back here, and then we send 4. Memgraph is not available. Nothing is here. But let's say if we bring Memgraph back in here, boom, 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 Memgraph is immediately consuming that message from Kafka, and that's interesting here because now we have the 5th message here, and also the same applies for Kafka. So if Kafka is down, I mean, then if you are relying on Kafka too much, then you have a bigger problem. But first, Memgraph still can receive stuff, and you can still push data to Memgraph and push queries to Memgraph. But also on the other hand, let's say Memgraph also stores all that data, and you have one more system, one more service in the system on which you can rely. And then, like, if Kafka fails, or if you want faster recovery, because of course if you have a service that is running, it's running, it's much faster to recover that particular service, or that service is has the logic to recover, than having the whole, let's say, messages reapplied again, because that's obviously a problem, and it will take more time compared to like disk-based recovery or something that will read data stored on the disk already there. So by having a proper database, you will minimize that, let's say, recovery time or downtime in general, at least in most cases. Okay, that's about it. Now I have a various other things to do, but what has the biggest priority, I think, and what's the time? Yeah, we are already 2 hours in. I'll actually make some coffee and then I'll continue. Be right back. I'll actually do like this. Well, yeah. Well, actually, you can stay with the duck. You can stay with the duck. He'll make you. He'll be the companion. Anyway, let's check a bit here. Yeah, please, if you have any question or anything interesting you would like to know about Memgraph, please ask. Anyway, be right back. And we back. Good. Sidak is a bit better than I. He can code for as long as he can stay here, and he's staying here for a long time. Anyway, what now? So I have here on the list database stuff. Some of the database stuff I think I won't showcase that. I'll just mention that, and then probably triggers and yeah, various procedures for application. Yeah, I will mention that, and plus showcase triggers, and that's it. Let's do that, and then I will call it for today. So I'll talk about I'll talk a bit more about query regular database stuff like indexes and constraints, and then also mention these operational things like replication and other things. Then I'll do I'll talk about like the stuff we will add very soon with 2.0 launch, and another thing I'll just showcase triggers. That's I think very important in the whole streaming setup and how to use that. All right. Let's go back here. We stopped here. Yeah, one more thing. Let's just check the social media. Anything on that side? Okay. So I'll just go through these features which I won't showcase, but you have the whole documentation to figure out stuff. Maybe I'll showcase, maybe I'll record specific stuff about these things. So let's go database functionalities, backup. That's what we already did by this connecting, but by recovering stuff. Kafka stream, that's fine. Enforcing constraints, that's so in addition to, let's say, all graphy things, you can run a bunch of algorithms and all these things. I'll talk about that at some point in the future, probably next week or next weekend. You can do regular database stuff as well. So usually you can enforce some kind of constraints on, let's say, people level, application level, or database level. Obviously, like further you go, better it is from the, let's say, consistent side or like correctness side, because you have a system that is helping you enforce some stuff. So in terms of that, Memgraph has these constraints, and that helps you to enforce certain rules in the database, in the system. So you can create a constraint on node that has a label, and that constraint will tell that a property named property has to exist. And basically, yeah, for example, each employee has to have a property first name and last name, and there are commands to do so, to show all the information attached to these constraints. There is also a unique constraint, which is basically enforcing that a node with certain label has certain properties, but also that they are unique. So, for example, each employee should have a unique email, address, and you are achieving that by executing this, by creating this constraint here, and that's basically it. That's it. And that this is very useful because you can have a lot of these, let's say, for IDs or like for these emails. It's very convenient to have this constraint, because otherwise you have later down the road you can have problems with inconsistent data or wrong things in your database. Obviously, since Memgraph doesn't have a strict schema in place, these properties can be anything at this point, but once we introduce a strict schema, we should also add a syntax that will tell which type each property has to be. But yeah, at this point we don't have the strict schema, and that has like positive and the pros and cons, because obviously you can put whatever in. It's easy to start, it's easy to model, but later on you have problems if you are not enforcing the schema on, let's say, application layer, or people are not enforcing that somehow. Inspecting queries, that's also regular stuff, because you can explain a query, you can get a query plan out of that, and also there is why we don't have a profile here? That's another item here, but yeah, you can search for that. That's fine. A memory control, also Memgraph has many ways how to ensure memory usage and memory limit. That's actually a really hard problem, because on the given operating system you have virtual memory, and processes can use, they see just unlimited amount of memory, and that's not good. And then because you can exceed that limit, you can exceed the limits of physical memory, but there is a way to specify like a global memory limit. Obviously you have to be careful, because some other process can interfere and can consume a lot of memory, and then less memory is actually left for a database instance. But that's the reason why usually you deploy like one service per machine, or you deploy that inside Kubernetes or any other environment, and which has the some controls in place. But yeah, you can limit memory by providing this flag. You can also put a limit on each query, or put a limit on a procedure call. These are all options you can use. And also you can explicitly call free memory. Memgraph will try to free up some memory which is not used, or with all fragmentation and all these things, it can be quite tricky to free stuff. So you can like hint Memgraph to do so if possible. That's about it. NetworkX is like, it's a huge project. It's a huge library for graph algorithms written in Python. Since Memgraph has a query modules that can run Python inside Memgraph, Memgraph can also run NetworkX stuff. And why is that convenient? Because Network has like a huge variety of algorithms and implementations of different things, and Memgraph tries to provide a deeper integration and tight integration with NetworkX, so that you can leverage all these things in the easiest possible way inside Memgraph. But yeah, that's all covered under Mage. Let's say our project on GitHub. We provide a bunch of these algorithms written in Python, C++, or NetworkX stuff, or we are using NetworkX to run the algorithms. Profile, that's also one a feature that is helping you figure out what are queries actually doing. You can run profile on any query to get what is going on. That's again convenient when you have like a slow query, or you just want to figure out what the query does under the hood, because Cipher is a declarative language, and then the question is, what is the actual semantic of underlying execution? What will happen actually? And then with, I mean, you can do that with, you can get that with explain, which is explained under inspecting queries, but profile gives you actual time, and then you can see the actual execution times and maybe detect some bottlenecks and stuff like that. Query modules, I've talked a lot about that on the stream, on the live stream so far. I think that's a very convenient feature if you want to extend Memgraph. That's something which helps you extending Memgraph and providing more things into the instance of Memgraph. We have Python, we have C, we have Rust. All these transformation stuff are done through the procedures, etc. All right. Implement the custom query module. Here we are explaining how to implement the custom query module. That's very verbose. Replication. So in addition to, let's say, durability and single machine recovery mechanisms, Memgraph also supports replication. So you can deploy Memgraph on a cluster of machines, and then in case something fails, other machines in the cluster can take the responsibility. We have many different modes: sync mode, async mode, semi-sync mode. All these have its own place in the deployment. You can maybe have like a cluster where two machines are in the synchronous mode, so every single write will be propagated to the synchronous replica. Or you can have, and then you can attach these to asynchronous mode. Obviously, benefit of asynchronous mode is like lower latency, because you can return the result faster to the client, but maybe that won't be written, because in that particular moment system can fail, etc. Configuring the cluster, here is all these things is explained. Replication is, and high availability is a huge topic in general. I should record video only about that, probably one theoretical video first, and then how that's actually done with Memgraph. TensorFlow, that's a project we actually did a way back. The idea is to provide like a convenient way how to transform graph into TensorFlow object into a matrix. I think this is a very convenient ways of interacting with TensorFlow. It's all explained here. Let me know if that's interesting, because I think graph are a perfect fit for running machine learning stuff on top of graph model. That's like perfect usage for graphs. Triggers, I'll cover that, and enterprise features. Let's do first enterprise stuff. So there are many authentication and authorization mechanisms. So Memgraph also has authentication module where you can implement custom authentication mechanism, and basically for whatever you need. And that's how we actually implemented support for LDAP. So that's there is the like a authentication module, and you can write it in Python, and then inside Python you can have a logic that will deal with LDAP. It's a bit easier to define this logic in higher level language like Python instead of C, and then it's very convenient to do these things in, let's say, Python. But we have a complete module that does LDAP authentication out of the box. That's on the enterprise side. And also user privileges. But this is a bit, I think, wrong. I'm spoiling now a bit, but basic authentication will be also part of the of Memgraph community edition, let's say, very soon. But stay tuned for that. And that's it. These are all the functionalities I wanted to mention. More will come soon. Let's just go and try some triggers while we're here. Right. So trigger. Triggers are well known, again, database mechanism, because what's interesting is that you need a way to push stuff out of the database. So Memgraph at this point is a pull-based database engine, and basically whenever you put stuff in, you have to also query to get data out. So whenever you want to get something out of Memgraph, you have to query Memgraph again. That's by default. But Memgraph also has triggers which allow you to be notified once something changed. And there are many different trigger types. So create, update, and delete. So whenever something happens, whenever something is created, whenever something is updated, whenever something is deleted, Memgraph will send a notification about that. In addition, so that's, we don't support, I said everything, but we don't support everything yet. We support nodes and edges. That's the actual syntax. So on node create, something will be executed. I'll talk about that soon. On edge update, something will be executed. Something is, again, a procedure. A query module can be executed, and then arbitrary code can be run. For example, in this case, in the current state, C, Python, or Rust code can be executed at that point when something happens. So a few examples would be on create, trigger the statement only if an object, vertex, and or edge was created during the transaction execution. So yeah, if you omit the node characters or the edge characters, then everything will be notified. Yeah, that's about it, I think. Yeah, here are all the combinations. So on create, we have created vertices, created edges, created objects. These are predefined variables. So now we have to, once for a certain trigger type, we have different objects that are created and sent back to the whole thing. Now here we have a bunch of stuff listed, but let me try out something inside Memgraph really quick. So if I go back here again, boom, create trigger, and here we have in the lab, we have all these triggers actually listed. So this can help you with creating the actual trigger. I'll actually create, I've never used update trigger so far. Let's try that out. So trigger name, update trigger, before, after. So it's also important to understand this before and after. Usually you want to be notified after a commit, because once commit has been done, you should be notified about that, because that's now part of the database state and it's 100% committed, and you know that's there, and once you get notified. But there is also before. And what does it mean? Before, a trigger can execute its statements at a specific phase before or after committing the transaction that triggered it. If the before commit option is used, the trigger will execute its statement as a part of that transaction before it's committed. If the after commit option is used, the trigger will execute its statement asynchronously after the transaction is committed. So that's it. So before the commit, trigger will execute stuff, will notify. What's the correct term for that? Trigger will notify let's say all the modules or the procedure that is attached to that trigger before the actual commit, and then commit will come later on. If after commit is picked, then you're gonna get notified after that commit. So I think in most of the cases you want after commit, because that's when data is really updated, because the problem with before is that transaction can actually abort, and then you will get notified about something, but that might not be the actual stuff at the end, because you have like concurrent transactions, you have a bunch of stuff, and there is multiple ways how a given transaction can abort, and in that case you're gonna get something which won't be part of the state later on. But maybe that's something you want for some specific reason, and that's a valid option as well. That's a valid option to be used. All right. In this case, let's do on update and then after commit query. So in the query state, in the query part, we can run arbitrary query. So here we can do query, or we can call a procedure. And what to do here? Since we can actually just print out. The simplest example would be to create a procedure that will print out these things. So let's do that. Do I have maybe an example of this here? Database functionalities, reference guide concepts. Do we have that? No. Reference guide, telemetry, no. Tutorials. Yeah. That's a bit weird here, because we are missing an example of a trigger. More about how. Yeah. I'll write that down as well, because we don't have an example. I don't see an example. All right. Okay. Yeah. Let's do that. So query. I can do something dummy here, but I'll go for a bit more complex example, which is a query procedure call. Okay, here we have Memgraph. We have to actually stop Memgraph here, because we need that thing here. MGP transformation. Let's do query modules. reference guide, query modules, custom query module. I need that read procedure. Yeah. I need that read procedure. Copy. I'll put that in the same module just for the sake of simplicity. So required argument nullable MGP any. Yeah, we need. I'll just send whatever has been updated, and I'll return args list vertex. No. MGP record, just a regular MGP record, nothing else. So, and I just want to print required arg for now. Very simple stuff. Very simple. All right. So we have awesome module trigger. Awesome module dot trigger is the procedure that should be available once we go back here and we execute that here. Sorry, we don't need this. Call mg load all. Okay. Mg procedures. So mg procedures yield star. Now we have a bunch of stuff, but we have actually loaded. We've loaded this thing here. I think we can, let's say, yield name. We can take name out of that, and then let's do where name equals it's a regex star trigger. Return name. Will that work? Invalid query, because we cannot have here, but we can with name where name this. Why is this an invalid query with name where name trigger return name? What's wrong here? Okay, if I just remove this for now. Yeah, that's fine. I think this should be fine. What about name equals trigger? Yeah. Isn't that the syntax for? Okay. Sorry. Query modules, Cipher, function clauses. We need clauses. Where? Regular expression. Sorry. All right, we have that tilde has to come after equal sign. If we run this, trigger regex error in trigger regex error. Boom. Okay. Why is that wrong? I think we need dot. Yeah. Okay. So this is a bit better now, because we obviously filtered out all the. Actually, the right syntax is, I think, this. Yeah. We filtered out all the things that don't have a trigger inside. Also, we can do, for example, nx alg. Now we got all the NetworkX algorithms packaged inside Memgraph, but yeah, fine. Anyway, that was a bit out of scope, but we have that procedure, and let's call that procedure so that we are sure that it's working. Match n, return n. We have that message. If we call awesome module dot trigger and we pass n, query should either create or update something or return results. Fine. Value none is not an instance of MGP record. Yeah, that's now a problem with our module. So we should return something. We have to return MGP record. MGP record. I hope this is going to fly. Load all. Boom. Load all. Yeah. Query match and return n. Because I don't have that query. That query was not successful. Awesome module dot trigger and nice. Now we returned everything. But what do we have in the, yeah, nice. So we have that vertex in Python. So we printed out every single item here, which means that's gonna work. And now we're gonna do the same in the trigger. So this was just an example that loaded a query module in Python. So let's go back to the code, no, actually we need to create that trigger. Now we are ready to create the trigger. So let's do this. So create trigger. We wanted to do on update, on create, on update, this one. Trigger name, trigger after query. Yeah. We want to call that awesome module trigger, but we need to pass n, and n is a node, but we don't have, obviously we don't have in this query a node. We have to figure out, or actually a better term is object, because we will, since we didn't specify a node or edge, we'll get all the updates as an object. But let's go back in the documentation where it says reference guide, triggers. No, database functionalities, triggers. Execute after commit, execute, yeah, and then within this table, because we have created objects, variables. So these are variables that are part of the let's say execution context, and you can get them automatically. You have them in the scope here automatically, and execute. Let's say unwind. Since we want to call that trigger, that procedure for each updated thing. On unwind a list that updated objects. Updated objects, where is that? Updated objects, on update, on create. Oh, yeah, updated objects is here, so that's available on update. Have we? No, I've updated objects as object. I think this is now correct query, because the unwind will unwind that. So created objects, updated objects. A list of updates consisting of set and removed properties on edges and vertices, and set of removed labels and vertices. Yeah, okay. Yeah, that's it. We want to unwind that list as a separate objects, and then we call that with a certain object, and then we just print that out. Boom. Of course, doesn't work. Query should either create or update something or return result. Update or make sure. We need this. Yeah, we have that. Make sure all predefined variables used are present for the specified event. On update. What? Am I missing something? On update for execute. Yeah, I have that. Yeah, updated objects doesn't work. Yeah, this documentation is also not helping me a lot. Not helping me at the moment. Dropping a trigger event type, trigger name, blah. Predefined variables. What is this? Yeah, this is the same file here. We don't need this. Don't need this. I'll just quickly check. We definitely have to add this example here. On update, yeah, I have on update. After commit, execute online updated object as object. As module.trigger, maybe my trigger is fine, maybe my module is just wrong. As a module trigger, just a second. Okay, let's do this again. Create updated objects as object as a module trigger yield star. Okay. Yeah, we need some kind of a return statement. Okay. Yeah, we definitely need to explain that in the documentation. Anyway, I think we now have a trigger. Show trigger. That's not gonna fly. Show trigger. So we have update trigger, which will run this, and then it will update stuff after. No, it will get notified on update after commit. Okay, overview. We have 5 nodes. Let's get one of these. Let's say timestamp to payload 1. Let's say payload 1. If we match n where n dot payload equals 1, set n dot prop custom. Okay, we still have for one, we have prop custom, and what did happen here? So Memgraph executed trigger, update trigger, and event type set vertex property, which is correct, key property, new custom. So that's the new value that we have, and the old value is none because it was not there before. And we have vertex, we have that object, that whole object here, which is great, which is exactly what we wanted to have. If we go back, we can do another thing here. Let's say match n. We can also put a filter here, which is payload 1, and then we can create that edge to some other node. So friend with another message data. So this will create an edge end node with payload data. In this case, I think the trigger shouldn't be executed, and it's not. If we go back, we have one edge, and to match that edge, and we expand into edge friend m set e dot weight equals 100. So that will set the weight to 100. Now if we execute this, again nothing here, but we have set edge property now, and we have that edge, and everything is again here listed out, which is amazing. So That's more or less it about the triggers, but I really have to expand that example with the trigger example, because it's not obvious whenever something fail. So maybe I can rerun this just to get that example. So blah on update. Uh-oh. Did I do that? Or yeah, this is a bug as well. We are not splitting the thing correctly. On update after execute on wind as object call object. That's also a bug. A bug here on wind. So lab. Okay. Yeah, if we don't have this thing here, return star already exists trigger 1. What? That's also working. We need to, yeah, we have a regular query, we have to return the thing. Yeah, that's a note that has to be written there. Okay. All right. Yeah, I covered more or less what I had in mind. I covered all the things what I had in mind. I mean, obviously I can go much deeper into the whole thing. My plan for the future is we'll probably add, so we have like 2 avenues. Let's say one is to showcase more about the operational stuff and deployment and how to use Memgraph properly with Kafka and how to deploy stuff, how to build applications and all these things. And another avenue is like scaling of the whole graph workloads and stuff like that. We'll see. I'll probably do some stuff with the deployment first and then cover scale a bit later. But yeah, I'll think a bit about that. And yeah, let me know in the chat, in the comments, on social media, wherever you like. Just post message info, and I'll be happy to incorporate that. All right, I'm happy with the time today. I actually did a lot in limited time, which is always good. And that's it. Please, as always, like, share, subscribe. I'll be happy to see more of you coming on the stream. I'll try to record some videos, some specific videos explaining things. And yeah, that's it. I think I'm gonna go a bit outside. Have a good rest of the weekend and see you next time. Bye bye.